So much younger with a shorter hairstyle.
Yes, ma'am, it's a summer cut.
Yeah, yeah. Why not?
That's the wrong name, Johnny Sins. Huh? Who is that guy, chap? I know that. I know that's not. Anyway, let's keep it. Very good morning, madam.
Good morning, Tuhin. How are you?
Not at all bad. How are you?
I'm good. I'm so happy to hear your voice after ages. It's wonderful.
After that's
I can't see you, Tuhin. Any problem with your video?
No. I intentionally don't switch on the video for the webinars because I shall share my screen only. So video is not required.
Okay, so you're not going to run the video?
No, it's the sharing of the screen. The screen will be shared.
Okay. Great. So very warm welcome, Tuhin, and it's such a pleasure to have you. And thank you for accepting my request. And as always, you were one of the brighter persons I came across, and you followed your passion and you did exactly what you wanted. Good for you. And so,
thank you so very much.
Yeah, Sriram and Rahul, please take over for the introductions.
Yes, ma'am. I was just waiting for people to join in, but I think we are short on time. So may I request, I'll just quickly read out a bio of Dr. Tuhin for the people who
Very briefly, so that we can allow Dr. Tuhin to speak.
Sure, ma'am, sure. Okay.
Mitushi will join a little later.
No problem, ma'am. No problem. Dr. Mishra has joined in. I would request everybody except Dr. Tuhin to mute themselves so that we have less disturbance. Okay. Dr. Tuhin Chattopadhyay, founder and CEO of Tuhin AI Advisory, is a celebrated business analytics and data science thought leader among both academic and corporate fraternity. Recipient of numerous prestigious awards, Dr. Tuhin is hailed as India's top 10 data scientists by Analytics India magazine. Dr. Tuhin spent the first 10 years of his career in academia and research, teaching business statistics and analytics at several reputed B schools of India. As a corporate practitioner, Dr. Tuhin has a proven record of accomplishment of a transformational leader in the organizations like the Nielsen Company. Currently, he runs his own consultancy. As an AI business analytics advisor, he is responsible for providing full suite of advanced analytics consultancy services to the clients. Dr. Tuhin is a prolific researcher and has authored several research books and has more than 30 research publications in refereed journals and conference proceedings. He is a life member of IEEE. He has spoken in several international conferences. He is editor-in-chief of International Journal of Business Analytics and Intelligence and is on the editorial board members of several leading journals. Welcome, Dr. Tuhin. It's wonderful to have you online here at JP Business School. I would now request the speaker to enlighten us with his words of wisdom.
Thank you so much, Dr. Sriram, for a kind introduction, and thank you, madam, for inviting me here. Please confirm if I can see my screen. Is it visible?
Yes.
Perfect. So the topic today is the applications of the business analytics and artificial intelligence in the industry. So my introduction has already been given, so I shall not spend any time here. These are some of my clients across the globe. Let me come straight to the topic. That's what I'm going to cover today. In the customer analytics, I'm going to cover the customer retention analytics and customer acquisition analytics on a high level. And within that, I'm going to cover the churn analytics, customer lifetime value, and the promotion response modeling. In the customer acquisition analytics, we will do the segmentation, recommendation engine, and purchase likelihood. In the financial analytics, we will cover the credit risk modeling for the pre-loan and the post-loan disbursement. And in the fraud analytics, we'll cover the only one part, that is the application fraud. And within that, I shall discuss that how robotic process automation and computer vision or image analytics gets leveraged there. So let's start with the customer analytics first. And in between, if you have any question, I think better you park your questions for the end of this session. Maybe after half an hour, the last 10 minutes, you can ask me the questions. So first thing is that why should that matter? Why should one be interested about the retention analytics? You must be all knowing, you must have all been taught that, getting a new customer costs a bomb. So it is always good to retain your old customers, and it makes very easy to sell to the new products and services to your existing customers. Now, the beauty of this, modeling framework is that typically what's been taught in the B schools or any of the college in the academia for that matter is that for segmentation, you do cluster analysis for a particular, say, purchase likelihood, you do tree. It doesn't happen like that. So whenever you go to the industry, a business problem has been given. You have not been given just to do a kind of segmentation exercise. So whenever a business problem has been given, you have to attack the problem by creating a kind of analytics framework. Now, please understand from this diagram, what do I mean by analytics framework? So for example, you have been given that you want to, or the business wants to retain the customers. So the first thing is that predict the churn risk and time, that everybody does. But do you think that all the customers who have got a high flight risk, of course, you can find out the customers who have got, who are highly, the probability is very high that they will leave the organization. That you can find from here. But do you think it is good to target all those customers? Answer is definitely no. Reason being that all the customers with the high flight risk might not have the high CLTV. That means the customer lifetime value. So it is always good to target those customers whose flight risk is high and who has got the high customer lifetime value. So from the step 2, if you can predict the customer lifetime value on the top of predicting the churn risk and time, so you can get the customers who have got the high flight risk and high customer lifetime value. The third step again comes that, is that sufficient to spend your marketing budget or marketing dollars to those customers who have got high risk of churn and high CLTV? Answer is no. Reason being that all such customers might not come back to you if they don't have any intention to respond to your promotions. So your marketing budget would be wasted. So the third part that we come here is that predicting the propensity of churn risk, predicting the propensity of response to the promotions. So finally, you get a kind of customer list where the predicting the churn risk and type, predicting CLTV, and predicting the propensity response to customers. Promotions are there. So precise list of target customers you get, where the high flight risk is there, high CLTV is there, and high to moderate probability of response to promotions are there. I hope this framework is clear. These frameworks are very fundamental before attacking any problem. Without the framework, if you just plug and play one model, that won't solve any real business problem. Now coming to a business problem, say the churn analytics, the first part. So out of this, step 1, step 2, step 3. If we just look at the first step, churn analytics, you can see again that this one business problem can be attacked through multiple approaches. And each of the approaches can be attacked or can be solved through number of modeling techniques. So again, it is not, as I always mentioned from the beginning, it is not like plug and play of one model for one problem and it is done. It doesn't happen like that. So what is the first approach of churn analytics is that churner profile in the non-churn database. So if you can do a kind of lookalike modeling, figuring out that whether any kind of churner profile exists in the non-churn database or not, that you can do, of course, by k-nearest neighbor or any of the lookalike algorithms. So that's approach number 1. Approach number 2 is the kind of churn scoring, figuring out what is the probability of the churn score. And the third approach is the predicting the churn time, that you can do by survivor analysis, deep learning solutions with. So if you know about survivor analysis, we have got, besides the probability of customer left or not left, we also take the duration part as the months, and then we have got 2 dependent variables there. The only other than MANOVA, there is only statistical or machine learning technique where I have got more than 1 dependent variable, so that you can predict not only the probability of the churn, but also when the customer is going to leave. So precisely you can tell that this customer is going to leave after this many months with this amount of probability. So this is the kind of example of k-nearest neighbor, how that works for the lookalike modeling. We just figured out the distance, and from the distance matrix, we can predict that yes, this particular customer is, the probability is very high for him or her to live. And then we have got the chart scoring algorithms, which we do it by different kind of classification techniques precisely. Reason being that I have got two classes here, the customers who are with me and the customers who have left. These are the two classes. And number of techniques are being leveraged. That's very important. Again, not one single technique. And then we compare across the models through several model comparison techniques. I shall walk you through few of them if time permits. And then that's how the model gets compared, validated, and we take it forward from there. And survival analysis briefly discussed how it works, and this is how the survival analysis works, in the sense that if it is kind of parametric model, we use the Weibull function or the exponential function. If it is semi-parametric, we use the Cox regression, and if it is non-parametric, we use the Kaplan-Meier. These are the different kind of deep learning solutions. So it's deep learning techniques, as you must be knowing, are primarily used for the artificial intelligence parts. That means for the computer vision, image analytics, or the speech mining. But besides the artificial intelligence or the image analytics part, these are also being used for the traditional techniques, traditional problems like marketing analytics. So it's a myth that deep learning techniques are only for the image analytics or the speech mining. They're very much being used for the traditional problems. And of course, why do we use it? Not for the sake of, or not for the fancy of doing it, but because the modeling accuracy increases multifold by the sheer sophistication of the techniques. Then comes the next part, is about the customer lifetime value prediction. Again, as I always say, that don't allow just one technique to use it. Number one. Number two, always think or always figure out the advanced techniques. So typically customer lifetime value, one can look at the time series or those things like what was the customer's past spend and develop a kind of projection from the time series. But those are kind of, honestly, they're obsolete. Nobody uses those things in these days. So typically these are the deep learning techniques like long short-term memory. Again, I'm not just plugging one long short-term memory here. You can see here, multiple long short-term memories are being stacked. So a series of models are being stacked, and from there we develop the output. And finally comes that which customer decisions can be prevented. So that's why we use the promotions response modeling. We look at what kind of channels customers use, what kind of conversions customers have done at past, and through which we just predict that yes, the customers are likely to respond to your promotions. And finally, we give the clients a kind of clear dashboards with a churn probability, net promoter score, customer lifetime value, and next best offer. So that's precisely the first part of customer retention analytics. Then we move to the customer acquisition analytics. In here, we will cover customer segmentation and profiling, purchase likelihood, and recommendation engine. Now, how does that occur? How does that take place in a sequence? Is that first of all, you need to create the homogeneous groups of customers. That is pretty well known to you, or you have done. The second part is that recommendation engine. Like, you have done the segmentation for what purpose? You are doing it so that the marketing gets customized. Marketing means what? You have to sell some product. But the question is which product? Because a company has got multiple products, multiple variants of the products. So the right product needs to be sold to the right customers. That's the beauty of marketing, right? That's the essence rather of marketing. So, but how will you know that what is the right product? Recommendation engine will precisely tell you this is the right product for any customer. And that helps in not only selling, not only for the first time selling, but for the cross selling and upselling as well. And finally, you get the purchase likelihood, in the sense it is not only about recommending which particular product to be sold, but also what is the probability of particular product to get sold. So precisely tell that Mr. X is going to purchase product A with probability of 0.8 by the third month or fourth month. Pretty precise. So that's the essence of this framework. So again, I'm hitting hard on this one point, which perhaps you might not, which will give you a kind of food for thought, is about the developing the framework before jumping into any modeling exercise. So typically, algorithms which we do is the cluster analysis and RFM analysis, which is mostly known to you. So I shall give you a very live example of a bank where I worked for a brief period in Southeast Asia, and this is what the kind of variables we got, and we are supposed to develop a cluster analysis for the segmentation. So finally, this is the kind of dashboard we came across. These are the 3 macro segments, and the first macro segment has got 3 micro segments. The second macro segment has got 2 micro segments, and the third one is the homogeneous segment. Now, these names that we have given is actually after doing a lot of exercise on the on the profiling part. We have done a lot of profiling here. Profiling, what does that mean? It means that whenever we actually segregate these segments into the different variables, how do they score, we can come across about how their profile look like. Like say, as you can see, the aspired segment is home to the youngest customers with the lowest income. Now you look here, the aspired, their income you can see and their age you can see, but their finances are very active in the sense that they take tough financial decisions with the high interest rate. Now interest rate you can see here. In this country, it is not very common in India to pay this much of interest rate, but the country where I work, it is very common to pay this much. And you can see here these customers, these young customers who have got a low income, but they are paying this much of interest rate. So perhaps they're all they're purchasing the iPhones or all the electronic gadgets which are otherwise costly but have a kind of fad in the market. So they purchase those things by taking some substantial loans. So I'm not again going you through the entire dashboards in the interest of time, but that's how the profiling gets done precisely. Now the next question came from the CEO. Once we have completed this segment exercise, is that how can you segment a new customers? So why this question is critical? Because for the existing customers, you have got the transactional variables, right? But for the new customers, you don't have transactional variables. You have only got the demographic variables, which come from the KYC forms. So what we did is that whatever, these segments we got, like 3 plus 2 plus 1, okay, all these micro segments become the dependent variable of a decision tree. So this becomes the dependent variable decision tree, and only the demographic variables becomes the independent variables. So you can clearly come out with the rules, like if the income is between 2 million to 5.1 million and the age is between 27 to 31, then with the 0.8 probability, I can say that the customer is going to be desperate. Now again, why is that important? Why should we do that thing? Reason being that even for a new customer, when he or she comes, it's important to customize the marketing. So that's the reason we should do the kind of decision tree or a kind of segmenting the new customers, even if they are new. I hope I'm clear. Of course, if there are any questions, I'm glad to take that after the session. Okay. Next part of this is the recommendation engine. I told you that once the segmentation is done, it's very important to recommend that which particular products needs to be marketed to which customers. So from this figure only, it's very clear to you what does a content-based recommendation does. Say for example, you purchased one kind of beer or one kind of Coke, and then the similar kind of products can be recommended to you. That's the content based. Say for example, recommended movies with actors, with same actors, for example, or recommended other sites with similar content. So that's how the examples of the applications go here. Then comes the collaborative filtering. Is that very simple, that if two profiles are similar, two customers are similar, and then if these customers have purchased, say, the pizza or some salad and some beer or Coke, so if this customer has purchased only pizza and salad, then the beer or Coke can be recommended. So that's the collaborative filtering part. Now you can understand. I'm sure if you are thinking while you are listening, you're also thinking. This part cannot be done if you don't do the segmentation. Now, are you understanding why I'm hammering on the framework part? Reason being that whether they are similar or not, this can only be understood if you are doing the segment exercise at the first. Then only you can understand that thing. So segmentation has to be done if you do the recommendation. If you want to do the recommendation engine. And then we do the hybrid recommendation. We mix and match both the content-based and the collaborative filtering, and then we create a recommendation. There are different methods, not going into detail, but that's how it goes. Last part is about the purchase likelihood algorithm of this customer analytics or the customer acquisition analytics. Is that whatever I'm recommending, whatever the products I'm recommending, what is the probability of purchase? So we precisely figured out that thing by the propensity model and uplift model. It is very simple that what is the probability of conversion. So converted, not converted is the kind of dependent variable we have, the binary dependent variable. Sorry. Thanks. Okay. Next, we are moving to the financial analytics part. Financial analytics, we will precisely work on one part is about the credit risk modeling. Again, I'm sure you also do the credit risk modeling in your classes, but perhaps one thing that doesn't get covered is the post-loan disbursement part. So both the things gets covered. One is the pre-loan, second one is the post-loan. So don't think that once the customer is given the loan, no analytics is required. It happens very frequently that the first few months the customer pays the loan on time, but then after the 6 months are over, then the delinquency rates increases. So how risky is the borrower is the critical question. That means in the pre-loan disbursement part, who should get the loan, how much loan they should receive, and what should be the interest rate. The riskier the borrower, the higher the interest rate. That's how things go. So for that purpose, we come out with an application scorecard here. And these are the kind of variables we consider: the demographic variables, the existing relationship with the banks or the NBFC, and the credit bureau variables. And this is the analytics framework again. These are the different kind of machine learning models we do. Again, to give the loan or to disburse the loan or not to disburse the loan, that's the question here. These are the tests for model development. These are the tests for the model performance. And finally, this is the beauty. Whatever the modeling techniques you do, that doesn't matter to a business guy. You have to give, suppose a business guy means who are the business guys here. These are all the direct selling agents who are in the field for the throughout the day, meeting number of customers. They need not work on your models per se, in the sense that they need not run the model and get an answer, nothing like that. So you have to give a kind of very user-friendly interface to them. User-friendly interface in the sense there should be a kind of, in the tab, the application will be there, the app will be there. In the app, they will simply put the variables, and then automatically the app will tell you whether the customer is a good customer or not, whether we can proceed with the loan disbursement or not. So that's the kind of easy to use framework, easy to use interface you have to give to the business guys. That's the kind of very important thing, because only model will not help unless you give a kind of interface with the business. And then comes the post-loan disbursement part. But before going there, let me tell you also another thing. Nowadays, we have actually augmented it, which I'm going to discuss elaborately in the fraud analytics part. So along with AI, we also use the RPA or the robotic process automation. So not that the DSA needs to physically type each of these figures. This gets, suppose, the monthly salary range. The moment potential seeker of the loan shares the credit card statement, shares the bank loan statement, automatically those numbers gets captured in the system. So robotic process automation works there, and that gets captured in the system, and then that gets kind of input for the app to take a decision whether to give the loan or not. So even we get rid of the DSA to punch in or figure or just typing the numbers. That is also not required. Next comes the post-loan disbursement part. The key business question is that how many late payments we expect a loan to have after a certain period. So typically predict time to default for the individual segment of the customers, like whether the customer is going to default after certain time or not, after 6 months, after 8 months, after 9 months, is a probability the customer is going to default. So that's one part of the thing. The other probabilities we figure out is that what is the kind of late number of days the customer is going to default. So not only after, but is the person going to default by 30 days, 45 days, 60 days, what is the number of days. And the third part is about whether we can sell any new loan to the customer or not. So that's the decision scoring. So for the behavior scorecard, this is the first one we call this application scorecard, and the second one, the post loan, we call it the behavior scorecard. So whether the existing customer will default in loan payment or not, say for the 6 to 18 months, for example. So that's the kind of work we do. And obviously the input variables for these models are very different from the input model of the pre-loan disbursement, because we have got lot of data about the customer once the customer starts transacting with the bank, like the debt to income ratio, a number of borrowers inquiries, interest rate of the loan, credit score. And this is how, again these things also, there is always an user interface. That's a very important part. Model cannot be worked without a user interface. So this is a kind of typical web app through which we can figure out that yes, with the months and with the change in the expected with the change of the credit score, how the expected number of late payments change. You can see here how with the credit score 8, it is reasonably good, expected number of payments are reasonably good. But if the credit score falls to 4, how that expected number of late payments increases. So that's kind of, it is not only about the credit score, so a lot of other variables come, and the typical web app or a dashboard will tell you that how the customer behaves. So that's precisely the financial analytics part. I'm sure I'm very much on time. And then the third part is about fraud analytics, where I shall focus primarily on the application fraud. What is the application fraud? Application fraud means that whenever a customer, say for example, let's take the same example of a loan. Whenever a customer wants to take a loan, there are many customers give many false documents, starting from the bank loan, credit card, and even the ID cards for that matter, even the images for that matter, everything customers try to get a bigger loan, and then a lot of falsification takes place at that stage. Falsification fraud takes at multiple stages, but I actually cover only the application part here. Now, the first thing that I was discussing with you is how to apply the robotic process automation here. Now, we extract the data from the scanned images, PDF files, Word documents, whatever the customers give. Even we can also figure out that whether the PDF document what the customer is sharing, is that a kind of tampered word or not? Is that really been converted from the word, or it has been tampered somewhere? So these things can be done by several logics, business logics are there, and there are several mechanisms also. So the APIs are there that extract information from the images of the iCard. So about the iCard, Aadhaar, or any kind of driving license, PAN, passport, whatever the customer is submitting, the API is there that extract information through the OCR is there, which will extract information from the salary statements like salary credit, how much salary gets credited, what are the point of sales debits, the EMI debits. So and all those things gets converted to a dashboard, and then the profile gets created. So that's the first step where RPA takes a major role. So not any manual intervention is required. Whenever a customer submits the documents, it gets checked in an automated way, checks for any kind of fraud in an automated way, and then that gets converted to a dashboard in an automated way. That's the application of RPA. Then comes the scanning of the images and the PDF documents. So here also a lot of logic we check because every iCard that the customer submits, every iCard whenever they get prepared from the government side, they apply a few logic, like what should be the PAN number, for example. The first few digits of PAN number, if a customer is born between some years, say if the customer is born between 1980 to 85, for example, then the PAN should start with A, like that. So if such things don't match, the business logic actually catch it very, very quickly. Even for the images, we do those things like foreshadowing or the tampering of the images. We can figure out by the analyzing the pixel of the images, what are the geometric alignment of the images, what are the object interactions, object interaction in the sense. Suppose some information should be there in the footer, so we know what does this mean. So we actually work with the logic and see that whether this logic actually aligns with the other information or not. And that's exactly what I was discussing, building a fraud scorecard for the customer. So we know that what are the kind of business logic that goes, but not the business logic, exactly the documentation logic from the government side that goes while they create this kind of iCards. So that gets checked. That gets checked in an automated way. That's the beauty. Not that I have to do it or anybody has to do it. We create a data pipeline. So the data comes, data gets extracted by OCR at RPA. It comes to the database. The logic are the algorithms are there. The algorithms work on the data, and automatically it creates a kind of fraud scorecard. And finally, the image analytics part or the AI part. So what happens is that nowadays it becomes mandatory for most of the governments of the countries. They have to, customer has to not only submit the iCards, but also take a selfie from the app. Now we also check whether the selfie is the same person who has been given in the iCard or not. So it's a kind of image comparison, the image that I'm getting in the iCard and the image that the person is sharing as a selfie with the same person or not, or it's a kind of picture of a picture or not. So that way, a lot of image analytics algorithms or computer vision algorithms you must be knowing, like convolutional neural network. Then there are RCNN, fast RCNN, faster RCNN. These are all the different kind of image analytics algorithms that go into the place and figure out whether the images are the same person or not. So that's one way of doing or applying the artificial intelligence and robotic process automation in the fraud analytics part. So thank you, and it's open for questions. Just before I close, I was giving some kind of hyperlinks there. So I was giving a kind of example that how the hybrid models take place when I'm actually mixing the deep neural network and RNN for churn analytics. So that's how the deep neural network. This is how the LSTM or the recurrent neural network. LSTM or long short-term memory is a part of recurrent neural network. So how these two things actually gets merged and we get the deep neural network. So that's how the hybrid model works. The second part is about, this is in context of the customer lifetime value, when I was discussing about the stacked LSTM or the stacked long short-term memory. So when I shared the stack, I have shown you the pictures of how the different slabs of the bricks were there. So this is how actually the models work. So these are the different LSTM. This is how the bidirectional, you can see how the bidirectional things works here. And then finally, it comes to one single LSTM, and all these LSTMs actually come to the final prediction. So that's our robust framework. This is a robust framework how it works. It is not about a kind of single model and then single model predicts something. You won't get any accuracy. Accuracy will be very poor with the real-time data if you just bank on or if you just rely on one model. And this is about the recommendation engine. We typically use the ReLU model here. So whatever I told you about the collaborative filtering and the content-based filtering, I haven't discussed the algorithms here. This is the different kind of algorithms that gets worked here. So thank you. That's from my side. Any questions? I shall be glad to answer them. Hello. Hello.
Hello, can you hear me?
Yes, now you're audible.
Any
Hello.
questions?
Yeah.
Any questions?
Yeah. Dr. Tuhin, I'm Professor Rajneesh Kumar Mishra. I'm teaching human resource management and HR analytics to the students. Just a very
Very
basic
good
and simple question. Yeah. See, when you have your clients with banks,
Yeah.
so whenever you are trying to do the data pattern and algorithm and preparing an algorithm, you have to look at their database that is already existing.
Correct.
And for the field, maybe no data. So
Right.
in that case, how would you develop an algorithm and try to find out the data pattern so that you can come to some conclusion?
The question is not clear. As I rightly asked you, understand your question, you were saying that when I said correct, it means that you are saying that I'm looking at the customer's database. That's correct. You're also saying I am looking at the new customers, new data. That's also correct. But then what kind of algorithms I shall use to generate insight? What does that mean?
Yeah. See, maybe some of the fields may not be available in the database for which you may require to have it in the database to take the analysis forward.
Okay, got you. So typically, traditionally what was been used, there are some rule of thumbs, but those things are actually out of the window. The traditional rule of thumb that, am I audible? I hope I am.
Yeah, please.
Okay, sure. So traditional rule of thumb is that if the missing value is more than 30%, don't take it, or improve the missing values with the mean median mode. Those things are not very, not very handy, not very advisable. These are not advisable. I'm not advising that, by the way.
True.
Don't say, okay, I'm not advising that. What I'm advising is that for such kind of work, for such kind of scenarios, you have to develop the models for the missing values. What do I mean by the models for missing value? Let me give you a very simple example that everybody can understand. Say, for example, you are doing with only two variables, sales and price. Now, some sales value are missing, and you are supposed to impute the missing value. Are you going to do it by mean median mode? No way. So what you can do is that from the existing data, that means sales and price data, you can create an equation. And then say, for example, you have got y equals to sales equals to some kind of m, that is the coefficient, into price plus c. You have got the equation. Now you have got the missing value of sales, but you have got the price, for example. It can be the other way around also. You have a kind of equation. So what you can do is that from the price, you can straight away predict. Now I have given an equation of regression so that it is understood by everyone. But regression is typically not being used because that's not a kind of very, very sophisticated method. Typically for such kind of scenarios, the nearest neighbor models, typically the Bayesian models are most reliable in the sense of they work with the probability, conditional probability more accurately. The Bayesian networks, the Bayesian models, Markov models, and the lookalike models are the best scenario to work on such scenario. But the takeaway from my discussion is that it has to be imputed through some modeling technique.
Okay, good. Thank you.
My pleasure. Any other question?
Any other question, please? Students, if you'd like to ask some questions. Okay, Tuhin, I have a question. Yes, please. Who's that? Please carry on with your question first.
Yeah, Dr. Tuhin, good morning, Dr. Tuhin. This is Dr. Rahul Sharma.
Your voice is breaking. Anyway, go ahead.
Am I audible? Am I audible now?
Not really. I'm having a hard time. Anyway, go ahead. I shall try to decode.
Okay. So I want to ask a question on behalf of my friends. In case if they want to go for business analytic course, then the prerequisite that they should have. Who should
to be very honest,
do well in business? The prerequisite.
I won't like to answer this question from the perspective of what subjects they should know, because that has been tried and dusted, in the sense that everybody knows, like they need to understand statistics, mathematics, but those things are not required to me. What is really required is the ability of critical thinking. If one can really think critically, analytically, the power of thinking is the most important thing. If one is having that thing, no other statistics, machine learning is required. If it is not there, whatsoever amount of coding skills, machine learning skills, statistical skills you are having, but if one cannot think clearly, then a person cannot excel. As simple as that.
That's a very, very interesting observation, Dr. Rahul. The students can be guided like this, that you don't essentially have to have any basic prerequisites, mathematical ability or exceptional mathematical ability, quantitative analytic ability. Basically, creative, strategic thinking, solution-oriented thinking is what is really required. Am I right, Tuhin? This is what you meant?
Yeah, absolutely. I assume that the assumption of this statement is that the student has the capability or the talent to pick up the mathematical and the coding skills. Of course, if the assumption gets violated, then my statement is not true. That means if the person cannot pick up the mathematical skills or the coding skills at a later stage, then no amount of critical thinking the person is having, it will not help. But only having the mathematical or coding skills, that is a kind of necessary but not sufficient condition.
Good. Anyone else?
Hello.
You have a question, I think.
Hello.
Yeah, you're audible. Please go ahead.
Yeah, actually, I do have a question. Like, we have learned about business analytics in our post-graduation, and I'm undergoing through data analytics as machine learning and AM loops and dev loops. So I just want to know, like, how is artificial intelligence linked to it, and what are the software that we can use and learn to go into that process?
Okay, good question. It's actually a good question. Thank you so much. See, for us who are into this field for decades, to be very honest, in our time there was nothing called AI algorithms. Now I shall quickly walk you through the history of the development, and you will understand why I'm devoting just 2 minutes of time. So in our marketing research time, it was the neural network. You must be acquainted about the different neural network algorithms like multi-layer perceptron, radial basis functions. We had those neural networks with maximum 5 hidden fields, not more than that. 1 to 5 was kind of max. The hidden layers were there. But then, in the recent last 5 to 10 years, the nature of the business problem changed. Like computer vision, the image analytics, the speech mining. Speech mining is not text mining. I'm talking about the intonation of the speech. What is the sentiment from the speech? Not going by the word, but by the intonation only. So for that purpose, we require very granular level of analysis, pixel by pixel analysis of an image. Now for that purpose, we require 5 hidden layers were insufficient. Hidden layers nowadays we work is about 100 to 300, sometimes even 500 and 1000. Now you can understand how is the kind of history or the development or the evolution of how it is linked. That was your question. I'm answering that question. It is linked in the sense that it is an augmentation. It is not a kind of new invention. It's an augmentation of the existing machine learning techniques, of the neural network techniques. Now you have got all the deep learning functions. Deep means what? The number of hidden layers increases and the architecture also increases.